The buttons in the Selection Control tool allow you to select faces, edges and vertices by specifying a zone, threshold or surfaces, or by growing and shrinking from an existing selection. These options are useful when you select many items. Various selection options are listed here. There are 4 selection options available for use with the zone, threshold and surface selection tools. You can access different selection options by right-clicking a selection control button. The options are Select, Add Select, Deselect and Subset Select. We will see these options in detail one by one. The first option is of Select. This option is the default selection option. The next option is of Add Select. This option adds entities to an existing selection. Right-clicking to close the program selects the faces. The next is Deselect Zone. This option deselects entities from an existing selection. Right-clicking to close the polygon leaves the following faces selected. The next is to select a zone. This tool selects entities on the displayed surface using a polygonal zone. The filter options control which entities the tool selects. The tool selects a face if all 3 vertices belonging to the face are within the zone, even if the zone does not completely encompass the face. The tool selects an edge if the 2 vertices belonging to the edge are within the zone. The tool selects a vertex when the vertex is within the zone. To end the zone selection, right-click in the graphics window or click the starting point. 4 selection options are available for the zone selection tool. Similar to select controls or options, there are also display options. These are useful while repair operation, as you have to control what entities are displayed in order to select them for repair. The display controls allow you to manipulate the displayed faces in order to make selections. At any time during surface repair, you can show or hide all faces at once. You can also show or hide a subset of faces based on the current selection or surfaces. You can grow and shrink the displayed face by one neighbor. You can also color faces by menu colors, the selected faces by patch, surface or part. Let us quickly list down various display buttons. Each has its own function. We will show the icon of each with its operation. This tool shows all part faces. Any currently selected faces remain selected. This tool hides all part faces. Any currently selected faces remain selected. This tool displays the faces currently selected in the graphics window. This tool hides the faces currently selected in the graphics window. You can redisplay the hidden faces by growing from neighboring displayed faces or by showing all faces. This tool shows faces on a part surface using the Show Part Surfaces dialog. This tool hides faces on a part surface using the Hide Part Surfaces dialog. This tool grows by one set of neighbor faces from the currently displayed faces. This tool shrinks by one set of neighbor from the currently displayed faces which are based on connected vertices. How can we display the entire geometry parts in StarCCM+? Displaying the geometry allows visual inspection of the geometry surface before generating a surface and volume mesh. The easiest way to display the geometry is with a geometry scene. By default, this scene contains a geometry and outline displayer that has the geometry and outline properties that are activated respectively. You can change the properties of these displayers to control the display. How to assign geometries to regions. We know that regions are needed for any CFD simulation. Hence, all geometric entities need to be assigned to regions. Why is this so? Let us briefly discuss this concept. The mesh continuum models cannot be used for geometry parts. In order to mesh geometry parts, they must be assigned to one or more regions, and the mesh is then generated for the region. This shown diagram illustrates the relationship between objects in the part tree and the ones in the region tree. A part must be assigned to a region. Part surfaces should be assigned to boundaries. Part curves should be assigned to feature curves within the region. The relationships do not need to be one-to-one. Multiple parts can be assigned to the same boundary, and multiple part curves to the same feature curve. Before a leaf level part can be used in the meshing process, it must be assigned to a region. A bidirectional relationship exists between parts and regions. You can say that this part belongs to this region, or this region is composed of these parts. Several methods exist to form such relationships. By using setRegion, by using the assign parts to region dialog, or by using the parts property in the region node. Any of these methods can be used to define the desired relationship between parts and regions. A leaf level part can only belong to one region at a time. Therefore, if a part is reassigned to a new region, it is automatically removed from the original region part list. Along with the part being assigned to the region, all surfaces and curves belonging to the part are also assigned to the region boundaries and features curves. The assign parts to regions dialog can be used to assign leaf level parts to regions. To bring up this dialog, right-click on the desired part node and select Assign Parts to Regions. There are some options while assigning parts to regions. Let us see them in detail. The region options control how the selected part is assigned to a region. The available settings in this are: create a region for each part. This option creates a different region for each selected part. Assign all parts to an existing region. This option activates an object selection dialog in single select mode. This option does not appear if no regions exist in the simulation. Create one region for all parts. This option is selected by default and assigns the selected parts to one region. Selecting this option makes a text box available for naming the region. Enter the name of an existing region or a region that you wish to create. Then there is the boundary option. The boundary options control the boundary creation of the selected parts. The available settings in this are: create one boundary for each part surface. This option creates different boundaries for each part surface. Create one boundary for each part. This option creates different boundaries for each part. Create one boundary for all part surfaces. This option assigns all the part surfaces to one boundary. Selecting this option makes a text box available for naming the boundary. Next, we have the feature curve option. The feature curve options control how the edges are assigned to feature curves. Let us see the meaning of available settings in this option. First is create a feature curve for each part curve. This option creates different feature curves for each part curve. Create one feature curve for all part curves. This option is selected by default and assigns all selected part edges to one feature curve. Selecting this option makes a text box available for naming the feature curve. Along with assigning parts to region, we also have to assign surfaces to boundaries. Individual part surfaces cannot be assigned to a boundary until the parent part has been assigned to a region first. As such, there are two different methods by which the surface-boundary relationship can be established. By assigning part surfaces to a boundary directly, or by selecting part surfaces for a given boundary. Either or both methods can be used. A surface, however, can only belong to one boundary at a time, so if it is reassigned to a new boundary, it is automatically removed from the original boundary list. After a surface face is assigned to a boundary, its color in the current scene changes from a light silver color to a darker gray color. This change indicates which surfaces have been assigned and which have not. To assign a surface face directly to a boundary, right-click the face node and select Set Boundary and then Existing. Similar to surfaces, part curves should also be assigned to feature curves. Individual part curves cannot be assigned to a feature curve until the parent part has been assigned to a region first. As such, there are two different methods by which the part curve feature curve relationship can be established. By assigning part curves to a feature curve directly and by selecting part curves for a given feature curve. Either or both methods can be used to define the desired arrangement between part curves and feature curves. Similar to boundary and surfaces, a part curve can only belong to one feature curve at a time. Therefore, if it is reassigned to a new feature curve, it is automatically removed from the original feature curve list. The feature curve to which an edge node is assigned can be reviewed or modified using the edge node properties. Selecting the edge node of interest shows the properties window for that node. Let us see how to use the region feature curve node. The part curves that are assigned to a region feature curve can be set using the feature curve node properties window. We have to select the feature curve node of interest to display the part curves property. To assign part curves to a feature curve, click the right half of the part curves property to activate the object selector. Select the part edges of interest and click Close. The part curves property now shows the part curves that are assigned to the feature curve node.